This is a recording for Edexcel Further Pure 1. Inequalities section 1.2, solving algebraic inequalities involving algebraic fractions. Well, as soon as algebraic fractions are involved, we need to be a little bit more careful about our solutions and indeed the methods of solution. So here you might think that multiplying by x minus 2 would lead us to x plus 1 is greater than or equal to 0, and the solution would be very straightforward. However, unfortunately, it's not as simple as that. Multiplying by x minus 2 is indeed a problem, because sometimes x minus 2 will be greater than 0, and other times x minus 2 is less than 0. And you will remember when dealing with inequalities at GCSE that as soon as you have a negative value, the direction of the inequality itself is going to reverse. So we can't just proceed in that method. However, we can use a method similar to that we use for algebraic polynomial inequalities. That is, looking at the critical values and then the regions defined by those critical values and deciding whether the function is positive or negative. So here we have the function, and the critical values are at x is equal to -1. That makes the top line equal to 0, and x equal to 2. So that has our boundaries -1, x equal to -1, and x equal to 2. The difference here, though, is that whereas x equals to -1 gives us the function equal to 0, x equal to 2 has 0 on the denominator of the function, and therefore it gives us an undefined value. So this is, if you like, a value which is not allowed within our function. Hence you can see in the question we have x is not equal to 2. The solution is very similar to before. However, we simply decide whether each of the factors is positive or negative. So below -1, they are both negative. Between -1 and 2, we get the first factor, x plus 1, turns positive. The other one is still negative, and then they are both positive. So in total, the function will be positive, negative, and positive. Now we're looking for a solution where we have greater than or equal to 0. So in other words, the positive values of f of x, which are in these regions here. But we have to be very careful, because we've got greater than or equal to 0, as to whether we include the critical values themselves. We've already discussed this. X equals -1 is definitely included in our solution, but x equals -2, or equal to 2 rather, is not included because it's an undefined value. Therefore, the solution will be the x values such that x is less than or equal to -1, union with the set of values x such that x is greater than 2. So you can see that then this is very similar, in fact identical to the previous video, but we have to be very careful about these critical values now, whether they are included or not in the solution. Now, it's not necessary to be able to draw the graphs of these functions at all. However, it might be instructive to have a look at the graph of f of x for this particular example. And here it is. You can see that the critical values here are at -1 as before. The value x equal to 2 gives us an asymptote rather than a 0. But you can see how the graph itself is changing from positive to negative back to positive. So here it's above the axis, here it's below, and here it is above again. So those critical values show the points at which it's changing from positive to negative. The solution, we want greater than or equal to, so it's going to include this value -1 downwards, but it's definitely not including the 2, but goes from there upwards. So a graph can be instructive, however, it's not the method which one would recommend, and you should be looking at the table of values or algebraic methods that we will look at in a later video. Well, here we have a rather more difficult example. However, although the graph is going to be more difficult to sketch, and we don't need to do that, the method is entirely the same as before. So what I'd like you to do now is pause the video and think about what the critical values are and what the table of values would look like. Well, the critical values then, the values for which each of the factors is 0, so they will be at x equal to 0, x is equal to -2, and x is equal to +3. So on the next slide, we've got the table marked out with each of the regions. So we have the critical values showing the boundaries here at x equal to -2, x equal to 0, and x is equal to 3. Remember that those on the bottom line are regions or values where the graph is undefined. So x equals -2 is not allowed, neither is x is equal to 3. The values of the factors are the next thing to do to decide whether they are positive or negative. And again, so what I'd like you to do, now we've got the table drawn, is to look at whether these are positive and negative and decide what the function itself is, and then look at the solution. If you pause the video, and then when you've done that, come back to it. Well, these are the factors and whether they are positive or negative. So for the function itself, we can see it's negative, positive, negative, and positive. We're required to find the values for which we have the function less than 0. So that will be this one and this one. And because it's strictly less than 0, we don't need to worry about those critical values. We can simply say that our solution is x such that x is less than -2, union with the set of values x such that 0 is less than x is less than 3. Remember, however, had we had less than or equal to, then we would have had to consider those critical values very carefully. So had it been less than or equal to, then the -2 would not be included because that is an undefined value. 0, however, would be okay, but 3 would not. So again, when you have less than or equal to or greater than or equal to, those critical values are very important to consider them carefully. Well, that completes this video, and in the next one we'll be looking at solving inequalities of the form f of x is less than g of x.